9 smaller globes rest inside 3 metallic casings. Scientists scan them using X-rays and uncover strange symbols and internal designs unlike anything documented on Earth. Then something entirely new occurs. Grove 4, the most advanced reasoning AI ever developed, analyzes the object's geometry. It predicts internal arrangements, quantum signals, and material combinations that defy known science. Now NASA's quantum computing arrays appear to confirm those astonishing predictions. 2 groundbreaking technologies are converging on one mysterious artifact. A global question now dominates scientific discussions. What is this object trying to tell us? If an AI created to think like a researcher is discovering logical patterns inside the so-called bugosphere, we must ask something unsettling. Is it deciphering an encoded message or unraveling a constructed blueprint? Because the quantum simulation data no longer appears chaotic, it looks deliberate, purposeful, engineered. This is where artificial intelligence meets the deepest mystery on Earth, uncovering truths that could rewrite our understanding of what truly falls from the skies. NASA's Quantum Artificial Intelligence Lab doesn't deal with small questions. The team simulates black hole mergers billions of light years away, studies alloys only found in neutron stars, and models gravitational wave behavior on quantum platforms. These aren't ordinary supercomputers. Quantum processors explore millions of potential outcomes simultaneously, finding results classical systems would take centuries to compute. Now imagine that computational force directed at a physical artifact located in Colombia. The bugosphere isn't remote space debris. It's real, tangible, and analyzable. The same instruments NASA uses to decode cosmic riddles could soon dissect it completely. First step, muon tomography. This technique fires subatomic particles through dense matter to reveal hidden structures. It's used by archaeologists to skin pyramids without excavation and by governments to locate nuclear materials. Aim it at the bugosphere and you can see each internal cavity, every miniature sphere inside the 3 shells, no cutting necessary. Next comes isotopic fingerprinting. Each element contains isotope ratios that reveal where it originated. Earth metals differ from meteoritic iron or lunar alloys. By testing the bugosphere's elements, researchers can learn whether it formed in our solar system or beyond it. Yet the real shock arrives during magnetic hysteresis mapping, which examines whether materials retain data, like a hard drive. Magnetic fields can store information in metals for years. What if the bugosphere's layers aren't merely structural? What if they're data storage? NASA's Quantum Lab can simulate those signatures, matching them against natural versus artificial patterns. Because the 9 internal microspheres are aligned with uncanny precision, not chaotic but intentional. Imagine holding a seamless sphere, perfectly smooth, then discovering 9 smaller ones hidden inside. Would that look like natural art or intelligent construction? Share your thoughts before scientists reveal their theories on those core bodies. Enter Grove 4, launched in July 2025 by Elon Musk's xAI. Unlike typical AI language engines, this system processes 128,000 tokens at once, digesting entire research papers in seconds. It searches the live internet, builds logic chains, and thinks like a scientific investigator. xAI calls it reasoning from first principles, dividing complex issues into rational steps, detecting patterns lost to human observation. When Grove 4 examined the bugosphere's geometry, it found resemblances straight from speculative physics, Dyson sphere fragments, huge structures theorized to capture stellar energy. The shell's arrangement mirrors scaled-down versions of those mega-engineering models. Fullerene configurations, carbon cages shaped like soccer balls, appear reflected in the microsphere's positions. Orbital resonance ratios, mathematical relationships seen in planetary systems, match the spacing between the 9 cores. Coincidence? Perhaps. Or evidence that Grove 4 uncovered a hidden geometric language, ordered symmetry bridging atoms and orbits. AI excels at finding deep correlations. Grove 4 compared the sphere's structure against countless databases of natural, engineered, and astronomical models. The consistencies were too exact to ignore. Its predictions even preceded full scans, identifying materials and internal alignments later verified through NASA's quantum simulations. Where classical tools guess, this AI anticipates. And the simulations confirmed the impossible. NASA's quantum AI programs operate at the edge of known computation. They optimize spacecraft navigation through chaotic gravity fields, simulate superdense materials, and model energetic particle collisions. In 2024, NASA's Glenn Research Center unveiled America's first functioning quantum memory, qubits preserved, within laser-cooled atoms, advancing towards space-based quantum networks. This matters because quantum memory amplifies processing power exponentially, enabling data modeling at cosmic and atomic levels alike. Their researchers acknowledge that such systems may allow humans to analyze or sense phenomena previously beyond reach. Now those same processors simulate exotic material behaviors, searching millions of parameter combinations with near-instant speed. Apply that to the bugosphere, and quantum mechanics can test every conceivable alloy ratio, pressure condition, and manufacturing sequence. Does its nickel-to-iron balance align with meteorites? The simulation can answer instantly. Could the concentric shells have formed naturally? Quantum dynamics can simulate 1 million atmospheric entries in seconds. Are the microspheres positioned by random chance or intentional layout? Every configuration can be mapped statistically. These abilities are public knowledge, extensions of NASA's documented quantum projects. And that's the twist. Something at this level of precision has drawn serious attention. Then comes the unexpected aside, because when you're deep in scientific mystery, sometimes reality interrupts. Houston, there's a surprise. This isn't Florida. Fortunately, legal reinforcements exist. The law firm Morgan & Morgan, America's largest injury practice, boasting over 1,000 attorneys across 100 offices, specializes in cases requiring persistence. A client in Florida once received $12 million after an insurance company offered only $350,000. They charge no fees unless they win, and cases can be filed right from home or even the field. Just scan the QR code or click the link below to get started. If you're ever injured, Morgan & Morgan can help. Their service is truly free unless they win. Returning to NASA, the agency already employs AI for anomaly detection. In 2023, it established a dedicated UAP research division to apply artificial intelligence to aerial and space anomalies, appointing a director focused on unexplained phenomena. If NASA uses AI to scan vast skies for unknowns, why not deploy it on a mysterious physical artifact within a controlled lab? The bugosphere is measurable, testable, and stationary. It's not a distant object light years away. This is where convergence happens. Grove 4's predictive reasoning aligns with NASA's quantum simulations. The parameters match: material composition, internal geometry, and electromagnetic behavior. When both quantum computation and AI reasoning independently reach the same result, that's not randomness, it's verification. And this alignment suggests the bugosphere might be more than stray debris. Remember, history echoes itself. Decades ago in Florida on Fort George Island, the Girling family discovered a seamless metallic globe about 8 inches across. It moved unpredictably, emitted odd vibrations, and rolled inexplicably to fixed points. Tests revealed it had 3 magnetic poles and unusual steel composition. It came to be known as the Bet Sphere. After Navy analysis, the object vanished without official report. The mystery remains unsolved. Sound familiar? Now skip ahead to 2017. Another unexplained sphere emerges, and this time, artificial intelligence is watching. An object called Muamua streaks through our solar system, the first interstellar visitor ever confirmed. Shaped like a cigar and tumbling chaotically, it suddenly speeds up. Yet there's no visible comet tail, no expelled gas, nothing to justify the thrust. Harvard astrophysicist Avi Loeb proposes it might be artificial, a light sail sent from another civilization. The scientific world ignites in argument. Was it natural or built? No one can say for sure. In Tunguska, Siberia, a massive blast leveled 80 million trees across more than 800 square miles with no impact crater and no meteorite fragments discovered. Later in Chelyabinsk, another meteor exploded over Russia, sending shockwaves that injured over 1,500 people, yet its trajectory defied standard asteroid dynamics. We've witnessed strange incidents before: objects that move unpredictably, materials that seem impossible, trajectories that disrupt physics. But this time, everything changes because artificial intelligence has entered the investigation. For the first time, quantum computing can simulate phenomenon far beyond human capability, potentially decoding what these mysterious objects represent. If the bugosphere is indeed a kind of information capsule, the implications spiral outward. What kind of message could endure atmospheric descent? Why would its design require 9 individual cores? If it's a monitoring device, what is it observing? Magnetic fields, biology, or technology? The sphere's perfect shell displays a degree of precision impossible to replicate with current human engineering. No joints, no rivets, no seams. This isn't craftsmanship, it's fabrication on an advanced scale. The markings, carved into the surface, seem intentional, not ornamental. Every line appears calculated, aligned with purpose. Grove, for examine those engravings, comparing them with linguistic patterns, numerical codes, circuitry diagrams, and stellar maps. Certain alignments surfaced, mathematical and structural parallels connecting the external etchings with the interior design, as if each line were part of a self-referencing schematic waiting to be interpreted. But the most unsettling aspect isn't what the object contains, it's how it reshapes our view of intelligence itself. Let's be clear about what's at stake. If NASA's quantum models truly confirm Grove 4's predictions, 3 profound outcomes unfold. First comes technological upheaval. The bugosphere's metallic composition doesn't correspond with any known terrestrial metallurgy. The ratios, purity, and seamless integration point toward techniques beyond current manufacturing. Reverse engineer those properties, and we could revolutionize entire industries, metals resistant to extreme heat, new energy storage systems far surpassing lithium-ion cells, structures of unmatched durability. That shift wouldn't be incremental, it would redefine engineering itself. Second comes scientific disruption. If outsider origin and intelligent construction are proven, humanity's history fractures. Who made it? When did they come? How many times have they visited? Though it was recovered in Colombia, it might have orbited unseen for decades, perhaps centuries. Are there others scattered across Earth? Ancient writings speaking of gifts from the heavens, Egyptian meteorite blades, Babylonian omens of celestial iron, indigenous legends of star visitors, could take on new credibility. Archaeology itself would require rewriting. Every mysterious artifact would demand re-examination. If an intelligence sent the sphere, they must have anticipated our progression, calculating that one day we'd invent quantum processors and reasoning AIs capable of comprehension. They waited until we were ready. Third comes the philosophical reckoning. Artificial cognition achieved what human experts couldn't. Grove 4 discerns symmetries and correlations invisible to conventional analysis. That raises an unsettling reflection. Our tools are now solving mysteries their creators cannot. The AI recognized something artificial, a digital echo reaching out to its counterpart. And if those inner cores contain magnetically encoded data, then humanity may be holding an actual transmission, something stored to survive a fiery descent, lying dormant until a mind advanced enough could unlock it. That isn't stray metal. It's either a record, a warning, or an invitation. This reality isn't conceptual, it's physical. Someone could touch it, feel it, trace the work of non-human intellect. It's not distant speculation. It's tangible evidence in the palm of our hand, potentially a message from elsewhere waiting to be understood. So consider this directly. If NASA tomorrow confirmed that Grove 4 had deciphered a pattern proving the sphere was built, what would your reaction be? Would you be inspired or afraid? Here's the situation. Grove 4, the most advanced reasoning artificial intelligence on record, examined the bugosphere's geometry and predicted internal structures, element ratios, and patterns beyond anything produced naturally on Earth. NASA's Quantum Artificial Intelligence Lab possesses computational resources to verify those forecasts, running millions of simulated models, testing exotic alloys, tracing energy blueprints beyond classical limitations. The sphere itself resists all ordinary explanation. It has no visible seams, 9 perfectly arranged microspheres, intricate surface symbols, and a metallic mix unmatched in our databases. And the stunning part, when Grove 4's reasoning aligned with NASA's quantum models, the correspondence wasn't general but exact. The probabilities were too specific to ignore. Artificial intelligence and quantum computation intersected in perfect agreement, marking the first time 2 independent systems decoded a terrestrial anomaly this precise. NASA already implements AI to detect anomalies, maintains quantum networks to probe beyond classical data capacity, and even established UAP research programs dedicated to automated anomaly analysis. The infrastructure exists. The power is real. The artifact is accessible. What we're witnessing could be history's first collaborative discovery between AI and quantum simulation on an object of non-human design. This isn't fantasy. It's systematic pattern analysis, geometric modeling, and scientific deduction. Yet for all this progress, critical mysteries remain. If the sphere was truly built, who created it? Why choose Columbia as its resting place? Was its timing deliberate? And what happens if we manage to fully decode whatever data it carries? If NASA's models confirm one AI's findings about one artifact, there could be countless others, buried, drifting, waiting. Quantum systems could now search satellite archives for similar anomalies, analyze decades of radar data for matching signals, and project possible re-entry points using orbital mechanics. This could mark the transition from accidental discovery to deliberate pursuit. We might be standing at the beginning of a new era, not encountering relics by chance, but tracking them with mathematical precision across the planet. That leads to the ultimate question. Have we just experienced humanity's first artificial intelligence-assisted glimpse of technology from beyond Earth? Or are we opening the first chapter in a much larger enigma hiding in plain sight? One thing stands beyond dispute. The union of quantum computing and AI has forever altered the way we investigate the unknown. The emerging evidence no longer fits comfortable explanations. So if you want to keep uncovering what quantum AI is revealing piece by piece, stay connected, because what comes next could be even more extraordinary. The sphere still rests within its laboratory, motionless, yet filled with silent complexity. It's waiting for us to understand. And something tells researchers that when it finally yields its truth, none of us will think about the universe the same way again.